All right, so today's topic is something that you're going to hear in the industry a lot, and that's the concept of test-driven development. Test-driven development is exactly what it sounds like, meaning that I write my tests first, and that drives the development that I have. And the acronym for test-driven development is TDD. Again, test-driven development, write your tests first. What do you want to see coming out of your code? Like, what is the anticipated and desired result that comes out? And then write your code. It's like having a blueprint before you start building a building. It's like having a roadmap before you start driving across the country. It's like having a recipe to follow before you start making pizza. Unless you know how to make pizza very, very well, unless you know how to like cook or drive really well or something like that, you always want to have an idea of where you're going and what your desired output is going to be before you get there. And it also helps you think through like potential pitfalls and bugs before it happens. So the concept that we want to think of is think twice and then code once. That's why we do that kind of pseudocode, because otherwise there's going to be if you're not absolutely sure of what you're writing, if you're not writing down all the steps that you need to handle, then you're not going to be able to write the best code possible. You're going to be like spinning your wheels for quite a bit of time. A lot of the top tech companies in Chicago follow this TDD process. So something like Braintree Payments, they were PayPal first, then they became Braintree, and then Braintree now owns Venmo. So a company of Braintree's size still follows TDD. DevMind is a consultancy here in Chicago. They have offices now in New York and San Francisco, and I think they're maybe London, or I might be mistaken. But they also follow this TDD process. And then finally, a company called Pivotal Labs, who is going to host one final project group of 3 people. You're going to go to Pivotal Labs and work out of there for a week and a half. They also follow TDD patterns. And TDD, I mean, the companies that use this are either really, really wealthy or consultancies that can build this to their clients. So TDD is arguably the best way to write software, but it is an expensive way of writing software because it takes a lot more time, as you'll start to see today.
Companies, Facebook, Google, like all these bigger companies, I mean, do they follow that or no, or that sort of?
It depends on your deadline, right? So everyone in the industry, most people argue TDD is the best way to write software. It's not the only way to write software. You have to have tests no matter what to automate, like to make sure that your code is working, but it's not, you don't need to follow a TDD pattern. So when I was at Groupon, they said, do TDD. Oh, by the way, this is due tomorrow. You know, it's like I can't write the tests and write the code in that amount of time. I'm just going to have to write the code and write tests later. So it's kind of like that's where a lot of things, a concept called technical debt comes into play, where it's like I wrote the code to meet a deadline. It wasn't the perfect code, and I might need to deal with it later, but I won't deal with it right now. And then a year from now, why did I write this? How come there's no test? This is broken. This is screwing up everything. That's a concept called technical debt. By doing test-driven development right off the bat and doing it right the first time, you don't have as much technical debt as you would in another situation. Google has done a study on this. I can find the exact numbers a little bit later, but essentially what they did was they had 2 teams, and they had a control group that did not have test-driven development, and then they had a group that did do test-driven development. They ran they both wrote code, and what they found was despite it being a slower process, there were far less bugs and far less maintenance that the teams that followed a TDD pattern had to do versus the ones that wrote the code first. Just to be completely honest before we get started on today's stuff, it's going to be very slow. It's going to be kind of painful, especially as you are starting to write your tests for the first time. You're going to say, like, I could have finished this in 5 seconds. Why do I have to write the test first? And it's one of those things where it's a muscle. You just have to kind of develop it right off the beginning. So the first thing, first kind of like acronym we need to know is, or not acronym, but the first kind of concept that you're going to hear a lot of people say is red, green refactor. And this is the idea that I'm going to write the tests first. I'm going to run them. They're going to turn red because I haven't written any code to make them pass quite yet. And then I'm going to write the code, and then hopefully it'll turn green. Like it'll make all of my tests pass, and then finally I can refactor it after my tests turn green. So red, green, refactor. That's how most people are starting to write your code. So let's create 2 things. we'll have two files side by side, and let's do something really easy at first. Let's just do, let's create a class called calculator. Again, I'm just kind of making this up off the top of my head. And then I'm going to create another file called calculator spec.rb. So the first thing I'm going to do is I'm going to require relative for calculator to basically bring in the entire calculator class into this specific spec file. Now the idea behind this is I want to write all the tests first so that it does exactly what I expect. I'm going to make, by the end of the day, all I'm really going to do is I'm just going to write a calculator class that adds, subtracts, multiplies, and divides. This is very, very simple, but we want to get in that process of like writing the code. So we have written what's called driver code so far. A lot of like let's say we have a calculator as a local variable, and I create a new calculator class, calculator.new. And we'll just do calculator.add 3 and 4 would equal 7. Calculator. Thanks. Calculator.
Wait, you don't use a calculator?
All right. This one will have, let's say we have 10 and 4 will give me 6. Multiply. 5 and 3 will give me 15. And then finally, maybe I'll have a divide for 6 and 3 will give me 2. We're used to writing this type of code. Usually we just kind of dump it in the bottom of the file and hope that it returns all true. This is something that's called driver code. It's not necessarily formalized tests, but it's code that we write to kind of drive our development to make sure that we're on the right path. So using this like kind of test-driven development process, I've kind of thought through like what am I trying to build here? I have a calculator class. It just does a few things, and then it returns me a number. I supply it 2 numbers. I tell it what to do, and then it returns me something. So as of right now, if I were just to run this file, let's list everything out. If I just were to run calculator spec.rb, I'm following this process of red, green refactor. Right now it's not red because I'm not using RSPEC quite yet, but it blows up. Something is broken. And the idea behind this, as we are starting to debug things and as people are starting to get more error messages on the page, I want people to not freak out whenever they see an error message on the page. So the general steps that I take is I take a deep breath whenever something doesn't work, because I know how difficult it is when you start writing code and it's like it just blows up on you. It's very stressful and kind of depressing, to be quite honest. The first thing I want everyone to do is just kind of take a deep breath and just read the spec and read the error that's coming out. So for this one, it says there's something broken in this file on this particular line, and the issue is there's an uninitialized constant called calculator. There's a name error. Now, if you know what this is right away, go ahead and fix it. If you don't know what it is, go ahead and Google it. For me, I know that if you go back over here, it says calculator.new, but there's no calculator class. So we'll create that. And at the same time, we will also kind of review object-oriented programming.
Yeah, so it's specifically in line 3. Sometimes you'll see something that says like line 10 or line 8, which when you look back at your code is the end of your code. Just know that just because it said like I have an error at the bottom of my code, that doesn't mean that that's necessarily like specifically where the error is. It's like where the code ended up when it had a problem. So it could be either of those two things, specifically where the error is, or like I ran through your code and I didn't get what I expected.
Mm-hmm. Okay, so it blows up here. It says that there's an uninitialized constant calculator on line 3 right here, and it says, I don't know what calculator is. That's essentially what this uninitialized constant is. So I have to using object-oriented programming, I'm going to create a reusable class that will house all of my methods, all of my properties, and things like that. I'm just throwing it inside of one class. So I'm going to create a calculator class and just do class calculator and end it. So I just have an empty class, and I'm just going to run the specs one more time. Okay. Now, again, we're not doing RSPEC yet, so I don't have those colors that are going to be built into RSPEC. It says that there's an undefined method add for calculator on line 5. So it went past line 3. We're here at line 5 now, and it says that there's, like, I don't have an add functionality. Like, there's no add functionality inside this calculator. Not a problem. So we'll just do class, def add. It looks like, and I'll just kind of keep going on from there. Again, this is a very painful process if you were to follow it all, like strict TDD. I make the error message on the page go away. I don't prematurely add anything. So it says there's an undefined method add. No problem. I'll run it again. All right. Now I have something different. It's on line 2, it says in add, there's a wrong number of arguments. I was given 2, but I was expecting 0. Kind of take a look at my specs here. I got add. I'm passing in 2 arguments, but this one doesn't seem to want anything. Great. So I'll take number 1 and then number 2, and then I'll try to make this one go away. I run it again. I get false. At least I get something out on the page. So now let's just kind of try to make this true. So 3 and 4 equals 7. Obviously, it's just going to be number 1 plus number 2.
Where does it return false? Is it just there's nothing? Is that...
Well, if we take a look at line 5, when I do calculator.add 3 and 4, does it equal 7?
Oh, I see.
Yeah, before I didn't have this at all, so it didn't return anything. So obviously, not returning anything does not equal 7.
Sorry, I got looking at the method.
So let's run this now and see if this passes, and we have a true statement. So this is, again, we're using driver code right now. We're going to translate all of this into RSPEC in just a second. Let's continue on. Again, this will be kind of a painful process and kind of repetitive, but it's the process that we follow to write the best code. We run the specs one more time, and it breaks on line 6. It says there's an undefined method subtract. Makes sense. I told it to subtract, but I have no subtract inside of here. Run the test one more time. There's a wrong number of arguments, so on and so forth. Number 1, number 2, and we'll get a false right here because we're not actually doing anything with the subtraction.
It's returning nil, and so
yep,
it's false.
That's correct. So hopefully I get true and true, and then something blows up on the next line. Instead of kind of beating this into the ground, let's translate these tests into RSPEC. So RSPEC is a, how do I explain this? So there's test-driven development, which is basically the concept of I'm going to write my test first and then write the code afterwards to make it pass and so on and so forth. And then there's also something called behavior-driven development. Behavior-driven development is basically I'm still doing test-driven development, but the way that I write it reflects a behavior rather than a specific output. So each major language and each major framework is going to have their own individual BDD, behavior-driven development language. For Ruby, it's called RSPEC, and Ruby on Rails is called RSPEC. Specifically for JavaScript, the big one right now is Mocha and Chai. Though that's the testing framework. JavaScript, Java for the coffee, and then Mocha Chai. There's a coffee theme going on there because a lot of developers drink coffee. But yeah, we're going to use RSPEC for us here.
And you're trying to get us, like that's the end goal, to write
Mhm.
everything RSpec. Test everything over.
I want you to be, there is so many similarities between RSpec and like Mocha Chai. Like it's kind of ridiculous. Like you can, the way that you write tests, there might be some different methods, but the way that you write tests will all pretty much look the same.
Sorry, go ahead.
No, so, and then somebody has to write the program to interpret RSpec or Mocha, and then you have to like download it, right? So we downloaded RSpec, right?
You gem installed RSpec.
Yeah, gem installed RSpec, yeah, okay. All right, got it.
So yeah, again, one of those things that we talk about, Ruby gems. Ruby gems are just it's a library. It's thousands of lines of code that someone wrote because they knew you had to do something repetitively, right?
Yeah.
So I know that I have to run tests using like, I know I have to run tests over and over again. So I created the RSpec gem. If I had to create fake data, that's why somebody created a faker gem. You had a question?
Did we use Jasmine for JavaScript in one challenge? Was that test driven?
Yes, that is test driven. Yeah, that is the framework for behavior driven. Like, so there's Mocha Chai and there's Jasmine. So there's two, they both do the same thing. It's just slightly different syntax. One might be faster than the other. I haven't dove into it too much. All right. So instead of doing all of this type of code right here with like the driver code, we're going to start writing full-blown RSpec code. And it looks a little something like this. And all I did here is I just copied and pasted from the other I copied and pasted from the other file. I'm going to change a few things just to kind of get things going. I don't need this require relative. I don't think I need any of this anymore. And let me just delete all of this. So the way that this works is it's supposed to read a lot like English. When I run the test, I should be able to read what's going on inside of this particular block, what's happening inside this particular specific test, and so on and so forth. I'm going to clear out a few things.
How are you doing that, John?
What? Oh, I click at the beginning of one letter, and then I hold Shift, and I click at the end to highlight everything. Okay. So the way that this looks is that this describe block all the way at the top is basically human readable. It's basically saying what's going on inside of this entire block of like stuff. Like what kinds of tests are being run here. So I'm going to write describe test out the addition, the hashtag addition method, add method.
So you can put anything in that.
I can put anything I want here. This doesn't
Just to be like a descriptive.
just to be descriptive for yourself. Like if you write code today, a year from now, you'll write so much code that you won't even know what you wrote. So you want to be as descriptive as possible inside this describe block. I want to be, I want to be descriptive. So I see some people just typing it all out, like test out the add method. Like this is absolutely clear, but also this is also perfectly acceptable. Describe add. This hashtag in the front is basically saying I'm testing out the method called add. But for us, we're just going to do test out the add method to be as descriptive as possible. Underneath the describe, there are a number of it, do, and blocks. Like you can have 1, you can have 50, it doesn't matter, as long as they are formatted correctly. For us, you can kind of think of it as like most general and then more specific and more specific as you kind of get further and further in. So the most general for us right here is like we're going to test the add method. And then this is also human readable, like it does what I expect. That's not a very descriptive, like specific thing, right? It maybe something like it adds 2 numbers together properly. So this is human readable. This is not actually executed. This is just saying like this is a description for people to read when we get there. And finally, we have the expect block. This line 5, where the expect is, this is where things really start to matter. So if I were to, so let's see. When you start writing your code, you want to follow the given, when, then pattern. So given is like, what do I need to be given in order to run this particular code? Do I need to call the method? Do I need to provide it parameters? Like, what do I need to give it? Followed by the when, like, what happens when I execute it? Am I just calling the method? Am I clicking on this button and then calling a method? And then is the result. What is going to come out afterwards? So again, given is going to be, what do I need to set up? All right. See you later, Thorn. See you tomorrow, right?
Hopefully I'll try to make it.
Okay. Sounds good. Well, hopefully we'll see you tomorrow. What do I need to set up my test properly? When, what is actually being executed? And then, what is the result? So for this one, we probably need something for a given. We probably need like a calculator equals calculator.new. Like I need the calculator class before I get started. Like that's one that I need an instance of the calculator class. That's what I need to be given in order to start off. When, what's actually being executed, that's most likely going to go inside of this expect block. So I'll do calculator.add maybe 3 and 4, and then what is the result? So this reads expect calculator. So I'm actually going to evaluate what's going to happen inside of here. Expect calculator.add 3 and 4 to equal 7. So given, this is what I need to set up my test. When, what's actually being executed inside the test, and then what's my result? And you'll see this looks a little something different from like p calculator add 3 and 4 equals 7. Yes, for something as simple as this, it's totally fine to write this type of code, but eventually when we start writing full Ruby on Rails applications, we want to get towards this type of testing framework and verbosity.
Now other methods besides expect and other methods on expect. I mean other classes besides expect and other methods on expect besides .to
equal. Yeah, there are many of them. So for us right now, all you really need to know is to equal, but there are a whole bunch of other RSPEC matchers available. So RSPEC matchers. So everything is going to be an expect. It's like I expect when this action is taken, some other thing happens. And the company that manages all of this is called the Relish app. And you can kind of see like, it looks a little like Ruby docs where there's a ton of stuff over here. There's actual to be, there's to equal, there's going to be greater than or equal to expected, to start with, to end with, to be between. There's quite a few of them, but for right now, for today, all you really need to know is to equal. And we'll get more and more advanced as we get more towards writing full-length applications and things like that.
Most of it's run on this expect.to.
Correct, yeah. Expect when, like something being executed, to equal or to match or to be XYZ.
There's no other alternatives to that expect.
I think there are, but I don't know off the top of my head. I probably have used them before, but I don't know off the top of my head right now. All right, are you good? All right, thanks for coming out. You're coming tomorrow, right?
Yes.
Okay, all right.
I just got here and I'm going to every meetup I can find.
Okay, sounds good. All right, we'll see you tomorrow then.
Thank you.
Okay.
Thank you guys for doing this for a That's awesome.
Okay, thanks.
Yeah.
All right, so I write the tests first. Like again, this is the idea of like, it's going to do red, green refactor. I'm going to comment all this out for right now. So we'll kind of follow that process of red, green refactor. So I've written the tests. This is written in the RSPEC DSL. DSL standing for domain specific language. So RSPEC is like the way that I'm writing this is specific to RSPEC. That's why it's called a domain specific language. let's run this. So I'm going to run Ruby calculator spec.rb. And it says there's an undefined method describe. Is there anything wrong with the command I just ran over here? Yeah. If you write RSPEC tests, you have to use the RSPEC command to run those tests. So we'll do RSPEC calculator spec.rb. And there's that red that we were talking about, right? And we want to make things as readable as possible. Again, this is all of the code that we just wrote. So test out the add method, and like it adds two numbers together properly. And then it says there's an undefined method add at line 11. So again, take a deep breath. Red is going to happen quite often. Take a deep breath, just read what the error is. If you know how to solve it, go ahead and fix it. If not, Google around for the answer. So there's an undefined method add for the calculator class. Okay, let's go to the calculator class. I see that I have no add method. All right, so let me. So I'll create that add method. And then run the test one more time. Again, then it prints out something else. It says there's a wrong number of arguments. I was given 2 right here, but I expected none of them. Makes sense? This is not accounting for those 2. So num1, num2. Now it says I expected to get 7, but I got nil as a result. It's because I don't have anything inside the body. So you're starting to see that red-green refactor. It's still red right now, but if I do num1 plus num2, that green is like gives a wave of relief over you. So it's red at first, and then it turns green when you fix it, and then refactor it later. Refactoring meaning, is there any way I can maximize? Like, can I make this simpler? Can I make it better? I don't think there's a way to make this better. You might remove the spaces or something like that, but overall, I don't think there's a way you can make a plus better. But usually for your specific, for your algorithms and stuff like those, there's definitely a way to improve your stuff. And because I have the tests already written, if I change the code and it breaks, at least I know it's like the code is either working or not working. That's the benefit of having this here. So I'm going to continue on and just do the rest of them. It tests out the subtract method. It subtracts 2 numbers properly, and you can kind of see over and over. I'm more or less doing the same thing. I'm just going to do subtract 4. Let's say 5 and 4 to equal 1, and then I'm going to test out the multiply method. 3 and 4 to equal 12, and it's like I have this roadmap that I'm setting out for myself, so that when I run the test, I will just go one by one to fix all of the specs, and then finally I will divide. It will, let's say 3 and 1 gives me 3. Yeah.
So it sounds to me kind of like the purpose of test-driven development is to have someone else like fully dedicated towards writing the test. So they're separate from the program writing and not influenced by your.
That is not 100% false. Yeah, that's not entirely false. So there are different levels of tests. The tests that we're writing right now are called unit tests, meaning that whatever code that I write, I want to write, I need to make sure that I have tests for. So if I'm adding something new to the code base, I need to make sure that I need to make sure that I'm covered. Like, I have to write the tests ahead of time. Then there's other people. If your company is fortunate enough or wealthy enough to have dedicated QA people or dedicated like testing folks, they will create what's called end-to-end tests. So what they will do is they will either do it manually, where they click through every single possible combination of things on your website to ensure that it does what it expects, or they will write automated tests, which is kind of like, I'm a user. I go on to the login page. I sign in, and then I I expect to see my home page. And when I click on my statements, I expect to see a list of statements. When I click on a specific statement, I expect that to download. Those are all automated tests that people have to write. So that when I have, the more test coverage I have, the more new things that I add in. If anything breaks, then I know, like, I don't want to merge that in. I want to fix that first. I don't want to break all the tests because I don't want to blow up the functionality I have behind things. So yes, as a developer, you're responsible for writing unit tests, meaning the code that you write, you have to test. But in terms of like an overall ecosystem kind of thing, that is the responsibility of QA, because they know the entire product. They know the thing that you're bringing in. Will this blow up other parts of the site?
I'll also note that, like, this is also a very good source of documentation when you're building projects or products. These tests are really giving you a really good understanding of what you expected your program to do. Whether or not that actually happens is up to you when you're building that logic out. But a really great scenario is you building out what your expectations are for a program, building out what edge cases you expect to have happen, or being able to really think through what could happen, right? What are the different scenarios that might come into play when somebody's interacting with my code, that I can make sure I am preventing, if it's a bad thing, right, from happening, so that you have all of your bases covered. The last thing you want, even with this add method, right? What if I put an F and a G? What's going to happen, right? Maybe there's something that says, you know, if the things that are being brought into this add method are numbers, add them. If not, tell the person that they need to give me numbers or something like that. This is a way that allows you to explore what those things might do. What are the effects of the logic you're bringing in to a larger code base?
Yeah. All right, so I have all of these tests here. I'm just going to run it, and we're just going to fix it up and just kind of follow that TDD process, and then I'll pass it off to any questions, and then you'll get started for today. All right, so I'm just going to run all of the specs, and okay, so I'm getting a little upset about this because there's 3 of them, and then it's like, sometimes when you run some certain files, you might have 20 tests that it say like, hey, you have 1 thing done and 19 things are broken. You know, that's kind of demoralizing. So the idea that I have behind this is I want to only see the most recent failing thing. I don't want to see all of them. You totally can. This is a manageable amount because it's only 4. But this, when you see a wall of red, it does hit you pretty hard at certain points where you're like, I'm never going to get through this. So what I'm going to run is I'm going to do RSPEC calculator spec -- fail - fast. This was something actually a student taught me the other day, last cohort when they figured it out. Fail fast basically will run through the test, and at the first failing test, it'll stop. So instead of seeing 4 examples and 3 failures, when I run this, it says I have 2 examples and 1 failure. This is something that I can kind of deal with. So you can do RSPEC calculator spec -- fail fast, or if you know that I specifically only want to test out the subtract method or specifically want to test out the multiply, what you can do is run the spec file, but you give it a line number. So attached directly onto the .rb at the end, I can just say like, okay, I want to test out the subtract method. So any line, because this only has 1 if block inside of here, I can choose line 15, 16, 17, 18. As long as it's between 15 and 21, RSPEC is clever enough to know that I'm talking about this block of tests right here. So I'm only...
You only say 1 line in between those.
Yeah, just choose a random line in between here. Now, if I have like another test in here, like if I have 3 tests or something like that, and I do line 15, it'll run 1, 2, 3 tests. If I say that I want to run just this test, I can choose any line between 16, 17, 18, 19, and 20. But because our describe block only has 1 test inside of it, again, RSPEC is clever enough to know, like, if I choose 18, it's just going to be inside of here. Or if I choose even 21, it'll run everything inside of here. So I'm just going to choose line 17, some random line in between everything. And I can just do line 17 like this. It's up to you however you would like to do it. I'm going to use the fail fast personally. And it blows up here. Again, red. It says, I take a deep breath. I say, okay, undefined method, subtract for calculator. Let's take a look at my calculator. Okay, I don't have it. Let's make that pass. And don't let's put it this way. True TDD, if you're following it, you've just fixed the error message. Like, it says that there's no subtract method. Okay, I'll put a subtract method in there. And then I'll go back and I'll run the specs. And now I have something different. And then I fix this one, then I fix this one, then I fix that one. That is a true TDD way of doing things. It's worthwhile to practice. If you're going to apply for Braintree, if you're going to apply for Pivotal Labs or something like that, you better be following as painful and as verbose of a process as this. If you know what you're going to be writing, make sure you can just go ahead and write it.
If the programmers at Braintree, are they sitting there literally doing line by line? Is that tedious?
Yes. It's not really
standing over their shoulder and they're ensuring that they're going.
Exactly. No, I mean, no one's going to do that, but the idea, like TDD came out of a software development process called extreme programming, or XP. XP basically says, I'm taking the best practices that I know and taking it to the absolute extreme. Hey, it's nice to have somebody reviewing my code. It's nice having somebody like having a second pair of eyes. We'll take it to the extreme. We're going to do pair programming all day long. Braintree does pair programming 8 hours a day, 40 hours a week. You know, Pivotal Labs does that as well. It is expensive, but the software is better because you can catch the things twice as fast. Imagine if you're working with somebody who has 15 years of experience and you're 1 year in. You're going to write stuff that has bugs, but because they're so experienced, they can see it coming like a mile away. It's kind of like it's not magic what I do when I can take a look at something that's broken on this line or it's broken on that line. It's not magic. It's just I have more experience. That's all. That's all it is.
On the other side of that, you're a first-year person, they're a 15-year person. They write something and you're like, hey, there's actually a method, or that was deprecated in the latest version of this software, or there was another way to do this now that I know because I learned like later on than you did. That now you've taught somebody who has a lot of experience. That's fast forwarding them in their experience that you're able to share as well.
Yeah. So like for example, there was a person I used to work with who was a director level for many years. So just dealing with people, but was still very technical, but had not written JavaScript code in a very long time. He decided to step down as director and came on as a JavaScript developer. But because he hadn't written JavaScript in like 6 years and many different developments had happened during that point, this person was writing code in an older version of JavaScript. It still works, I mean, but it's just kind of like, it's not best practice to teach your younger developers like, hey, using super old like syntax is totally okay, like. So we had like, we didn't have pair programming, but because we had pull requests, it's like, hey, this is deprecated, make sure you're using the most up-to-date. It's like, oh, it took him a couple months, but he finally got fully up to speed. And this is a director level. So yeah, so yes, test-driven development is an extreme programming tactic, meaning I want to test my code, so let's write all the tests first and let's go one by one. So in the very strict extreme programming world, this is the way that you actually write code. Again, it's kind of painful, but it makes for better code down the road, and you can just kind of put your brain in like, I'm going to solve one step at a time. But for time's sake, I'm not going to do that because it's going to take forever.
It almost sounds like that would be something that would be like right after. Well, actually, would you want to do that before or after you pseudocode the actual code that you put together for the program?
Spec kind of
replaces
pseudocode. So now instead of me writing comments about like, I expect this to happen, when this happened, the other thing happens, I can create tests that will say all of that. Now, all I have to do is run those tests and then implement based on those tests. Yeah. So instead of me looking at all those in comment form, I'm looking at them in RSPEC documentation.
Yeah.
So, and then in the future, if I break something or add some feature, I know that I'm keeping the rest of that documentation in mind, and I don't have to go back to the comments I wrote at the beginning and figure out how do I make sure that this works based on what I thought I was going to do in the first place.
Mm-hmm. Yeah, that's pretty much it. Yeah. In terms of pseudocode for like figuring out what steps you need to take, you can still write those things, but the expected output should go inside of here. So again, I just made this test fail, and then now I'm going to go on, and now it says 3 examples and 1 failure rather than 2 example and 1 failure. Undefined method multiply, no problem. Def multiply. I know I'm going to take in num1 and num2, and then I'm going to do num divided by num2. I know I'm doing it on purpose. Okay, I type in something wrong, and this blows up. Oh crap! Like now it's kind of like, this is where TDD also really helps, because it gives you very specific issues. So I said I wanted to multiply 2 numbers together, and I typed in an incorrect variable name in general. So it says undefined variable or method num. Did you mean num2 or num1? Okay, where is this broken? It's broken on line 11. Ah crap! I must have done something wrong. So I fixed that one, and I ran the tests, and it says, hey, I expected 12, but eventually I actually got 0. That's weird, because I know that I'm not stupid. Oh, I am stupid. I forgot. I put a division symbol rather than a multiplication. You can kind of see how this is going. And then finally, red, green refactor one more time. Hopefully we can get rid of this. Undefined method divide, def divide. Takes in a num1, num2, and then num1 divided by num2. 4 examples, 0 failures, all green, we're good to go.
100% test coverage.
100% test coverage. However, you'll notice that now we go back. Now we can refactor it. We have a baseline. All the specs are passing at this point. It's a good point to commit. We might want to commit at this point and say, like, hey, we want to save our progress at this point in case we blow everything up. You'll notice a few things. Actually, I'll keep that there. I'm repeating calculator.new 4 times, and right here as well. I'm also passing in the number so many times. It's not the greatest thing in the world. And I'm also kind of like missing the initialize here. Does anyone know why this works without the initialize? Yeah, I'm just not necessarily. So it's kind of like I can call calculator.new, but on this class calculator, I don't have an initialize.
Can't access those variables from like definition.
Yeah, you can still create a new instance of the calculator class. I'm just not passing anything in. It's kind of sad, but like each animal can have a name, but if no one is there to name the animal, then it's still in existence. You just don't know what its name is, or it doesn't know what its own name is. So if you go to like a pet shelter and then you have like puppy number 1 or something like that, you don't, like, puppy number 1 does not know what its name is because it has not been given a name quite yet. It's still in existence, it's still there, but you have to name it. And if you want the puppy to respond to a name, you have to like tell it this is your name. All right, so for us, we're going to do def initialize, and this is going to take in 2 arguments. It looks like num1 and num2 is used pretty much everywhere. So I guess I'm going to take in 2 arguments, number 1 and number 2. And then I can do at num1 equals num1, which is instance variable of num1 everywhere. And then I can do at num2 equals num2. I'm not going to do any attribute readers or anything quite yet, but I think I can refactor this so I don't need all of these anymore. Bam, very clean. Num1, all of these can be at symbols, and all of these can also be at symbols. Uh-oh. Did I mess something up?
I wonder if the /
Perhaps. Does this do anything? Nope. Who cares? That's why we have the specs. The specs are there to test us and to give us sanity. Run this. Wrong number of arguments. Expected 0, but I was given 2. Okay, so it's broken on line 9 of the specs. Okay, no problem. I'm going to do 3 and 4. This one is going to be 5 and 4. This one is going to be 3 and 4. And then this one's going to be 3 and 1. And then it looks like, well, let's just kind of go step by step. There, it says calculator.add 3 and 4. There's a wrong number of arguments. You gave me 2, but I expected 0. broken on line 7 of the calculator spec, of the calculator class. If I look over here, I don't expect any arguments because I initialized the whole class with those 2 arguments. So I can actually get rid of all of these. Get rid of this, get rid of this. If I was doing strict TDD, again, I would watch it fail, fix it, and stuff like that. But it's like I'm intelligent enough. I know how to do that, and so are you. For example, 0 failure. So there's that refactor we're talking about. That's step 1 of the refactor. Number 2, I have a whole. Sorry, Peter, go ahead.
Yeah, so it just goes back to the question you had initially asked about how come you don't need the initialize. So now you've got the initialize, and now you can remove the when you're refactoring, you can remove the numbers that you're passing,
Mm-hmm.
but you're still passing them through the calculator.mu with the right. I mean,
Right, but I only need to do it once is the main thing. So, sorry, can you ask the question one more time?
So first of all, what did you delete when after you initialized it? What did you delete from the spec file?
What did I delete from the spec file? Let's see. So I removed so remember before I had to pass in divide with 2 numbers like num1, num2 here?
Yeah, right, got that.
So I got that. So I deleted this because I'm initializing the calculator with the 2 numbers that I want to use later on.
Okay.
So I'm initializing it here with num1 and num2. Before, if I didn't have this initialize, it still works, but I don't have access to instance variables right from the get-go. And that was kind of the parallel I drew. It's like if you were in Southeast Asia, there's a lot of animals on the street. Some of them may be pets, some of them maybe not. The pets have names, the stray animals do not. They're still both in existence, but one has a name and one does not have a name. That kind of
yeah, it makes sense.
Mhm.
Just, see it one more time.
You call calculator.divide 2 arguments, and then have those. Actually, that wouldn't work anyway. If you did them as at num and at minus, would it recognize that what you're passing in should be an instance variable? I mean, if you get rid of initialize and just pass in some arguments to add and have at num plus at num2, would it recognize them?
So you're saying, okay, so I removed the initialize.
Probably not.
I'm going to get rid of this because I don't have an initialize anymore. And you're saying if I pass in the numbers 3 and 1 directly onto divide like this, can I do at num1 divided by at num2?
Or can you even add the adds into the input?
Yes, you could. You could do at num1 equals num1 here. So you can declare it here instead of the initialized if you'd prefer. It's just most of the time when you create something new, you would want to have those at things right at the beginning.
Pass them in directly as at num in the
Are you saying, can I run it like this?
the arguments, the parameters.
Like this?
Yeah.
I don't think so. I think that's why it's not highlighting as the blue version. It might. Let's find out. Let's run just this test. So I'm going to run just line 30. Formal argument cannot be an instance variable. I haven't seen that before. Good question. Let's go back to the way things were. All right, let's make sure all of this is still working. For example, 0 failures. And go ahead, please.
Did we figure out why? So why is it red? Like at num2 was red.
I think it has something to do with the division symbol here.
It's not missing.
It's not missing anything. That's why I ran. It's probably Sublime's text thing. Yeah, maybe let's just Ruby on Rails. I don't know. It's just probably Sublime text interpretation of this thing is blowing up. Generally speaking, if you see if you see something coloring that looks like this, there's generally something wrong, which is, this makes me a little scared, but I know that I have the backup of the tests. The tests are written and they're well put together enough to know that if this doesn't work, then there's going to be a reason. We'll do 2 more refactors, and then I'll pass it off to you all. So you'll see that I have @num pretty much everywhere, and this is totally fine. This @num, this is an instance variable, meaning in this particular instance of calculator, everything knows about @num1 and @num2. I can shorten this so I don't have to type this symbol by having an attribute reader of num1 and num2 as symbols. So the moment that they are declared inside of lines, inside the initialize, I can call it as just a method. Oh, the coloring went away. Interesting. Let us see if this works. This is why we have those tests again, so that when we refactor things, like, we can make sure it still has the same functionality. Cool.
Okay, I know you've explained that, so I don't understand what's the adder reader. I mean, I see what it does, but what's it?
So adder reader is short for this. Def num1 is @num1. Num1 is a method which reads the instance variable. So this will only work once you've declared an instance variable. So again, I'm creating a new calculator. I'm saying, let's say the numbers 1 and 2. So @num1 is going to equal 1, and @num2 is going to equal 2. Now, if I wanted to call it without the @ symbol in the front, like I have on 14 and every other one, I would have to create this particular method called def num1, which just returns this. Again, I can do that, or I could do this and not have this at all. So what you do here by having this adder reader is basically, Ruby knows that a lot of times I want to read the attributes of this particular class. So when I want to read it, like, this is shorthand for this. So adder reader of symbol num1 is equal to literally these 3 lines of code. So this is just shorthand. So I can remove that. And then this looks pretty good to me. We refactored it, we ran it, all the tests are green. There is one thing that I think I can, no, I think this is fine. This is okay. I'm going to open it up for questions.
Just more like for practical purposes, or for more like actual real application. Like when you use the @ symbol in Slack or on LinkedIn and you tag somebody, has there already been like a method that's been created for your profile and you're just tagging that?
Those are 2 completely different things. So the @ symbol inside of this is the @ symbol inside of Ruby. The @ symbol inside of Slack is just the way that they allow you to direct message somebody.
So is the @ symbol is just for initialize, right?
So the @ symbol in the front makes the variable an instance variable. Instance variable meaning for every single new, like if I create a calculator, that particular like we are instances of class person, right? Like each one of us are individual people, but we are all instances of the overall class person. There's things that I know about myself, like my name is John, your name is Mickey. But when someone created you when you were born and given a name, or like if you choose to change your name at a later time, like that's something that's specific to you. It's specific to your instance of person. But those are 2 different things. For the Slack one is literally just how you use the software. There's nothing special about, there's no programming related to that. I mean, there is programming related to that, but has nothing to do with Ruby code. I guess maybe I'm misunderstanding the question.
I was just trying to draw a parallel. Maybe one doesn't exist, like between like how you were flagging someone's profile to alert the user.
I don't think there's a correlation there.
All right.
And you said like the main purpose to do initialize instead of like do the period 1 to 4. So to make the code like cleaner.
Yes. Yeah. If there's things I'm going to reuse over and over, I generally want to put it inside the initialize. If there are things I'm only going to use once, then I will only put it inside of that particular method.
So you're almost always going to have an initialize.
I'm almost always going to have an initialize. Yeah. Cool.
Can I call one calculator.new for the entire?
What's that?
Can I call one time?
I can. Yeah, I can totally do that. I have specific ones for each class. Each it block has its own calculator because it's a different outcome. But I can totally do 6 and 3, and then do it once, and then have a 9, 3, 18, and 2. So that one, unfortunately, that one's going to go, I think, all the way up here.
If you want to define the class that way, they would want to remove the initialization and actually have each method pass on a number. So they can use different numbers each class.
You could, but I mean, it's more or less the same thing, no? Like all you're doing for this one is you're just testing the methods on there. You probably can have one method, and then it will go one particular calculator, and it will work for all of them. I think this is how I do it. So let's do 6 and 3. I just want to see if this works before I explain it. Let's do add would give me 9. Subtract would give me 3. This would give me 18. And this would give me 2. Undefined method let. I have to put this under this describe block. Yeah, okay, so this is what I wanted to avoid a little earlier. Testing out all of the methods in the class. Yeah, so this is what I wanted to avoid a little earlier, which is why I had specific calculators in every single class. So let me copy this over here just so we can have a side by side. So this is, ooh, this is what we had a little earlier. Each individual it block had its own new calculator. And yes, there is something, when I see repeated code over and over again, I see calculator.new, calculator.new, calculator.new. It's probably a sign that I can refactor it. This is an example of a code smell. It's kind of like when you've been writing code long enough, you start to see patterns that are like, okay, that's going to be a problem later on, or like I can sense that you're new or something like that. It's kind of like I recently learned about stolen valor from the other class, and I was kind of like, you can tell very quickly based off of how someone talks about their experience in the military if they are just totally lying to you or if there was an actual experience, right? Like I can't pretend well enough. Like you can smell that I'm not military, right? And just similarly, when other people come in, they start like talking about MOSs, and then it goes way over my head. Like you can tell that's the lingo that they use when they were in the military. So there's smells of people who are not military who pretend to be. And similarly here, there are smells that code is not totally refactored. When I see calculator.new a whole bunch of times, there's definitely a way I can make it better. So what I've done here is I've created a variable that can be used between different describe blocks called calculator. And that's what I have here on line 5. Now, if you want, like, if you don't have to do it this way, it's totally okay to do this right now, but I will eventually start challenging you to start doing things like this. I had to put let calculator outside of this describe block. So that's what I did at first. Oops. So I did let calculator. Oops. I'm just going to copy this. I thought that if I had a let calculator outside all of these describe blocks, that I could use calculator within all of these smaller describe blocks. The issue was when I ran it, I got this error that says there's an undefined method let, which means that I had to put let inside of a describe block and put all the other describe blocks inside of here. So it's like there is a way to do it. It was a little bit more advanced than I wanted to get. So the idea is I declare the calculator once, and I can reuse it within every other thing underneath. You don't have to do this.
Okay.
Yeah. Cool. Any other questions? Cool. Let's take a look at what we've got for today. So we're a little bit behind on pull requests because there's just so many of them. We're going to continue plowing through them today. Again, today is pairing optional. If you want to work by yourself, please do. If you want to partner up with someone, make sure that person wants to partner up for the day. They may want to have a day to solidify things in their heads. So you're going to have 3 challenges for today, but you're going to use TDD and RSPEC to test them. So it's not, there's only 3 of them, which is like far less than you've been doing recently, but you have to follow TDD. And I want you to follow strict TDD to the point where it's like, write one thing, it breaks. Fix that one thing, get to the next thing. Yeah, so I want you to do it that way just to have that skill in case somebody asks you during an interview. By not doing it, yes, you'll get through the stuff faster, but you might do yourself a disservice. Braintree might say, like, Peter, like, we like your background, you know, you have financial background, we do payments, like, come in for an interview, and then when you do TDD and you like do it not the most strict way, they'll see it right away. There's not a way that you can hide that as well. So I want you to practice doing as strict TDD as possible. So Armstrong numbers, most frequent integers, and shuffle, and then study up for whatever you may need. Let me stop recording here.